Hello and welcome to this tutorial. We are continuing the series of Spark plus PySpark. Today we are going to discuss about adaptive query execution, that is again going to be a optimization technique in Spark. Adaptive query execution was introduced in Spark 3.0 version. Before understanding the definition and other things of adaptive query execution, let's understand when we run our job what actually happens. When we run our Spark code, at that time a lot of static planning is involved. When we run our code, Spark do a lot of static planning. Now you might be thinking, why Spark do this lot of static planning? It does it because it can optimize our Spark job. But when we run this code, at that time we have to take care of multiple things to optimize the performance. After doing the static planning, we also need to optimize the performance. We also need to optimize some things at the runtime. There might be scenario after the static planning we have to optimize things. And what can be that things? We need to understand what is the condition of our cluster, how many worker nodes are there, how many driver nodes are there, what is the size of data, what is the number of partitions, is there data skewness problem or not. So once we execute our query, we cannot change all these things which are required to optimize the performance of Spark job. But Spark have a special or cool feature that is known as adaptive query execution, and that feature is going to optimize the performance of Spark jobs at the runtime. So I have written here, Spark will dynamically adjust your query plan based on the runtime statistics. Let's see how exactly this works. What Spark AQE will do? AQE will optimize the performance of Spark job at runtime using the following features. It will check if repartitioning is required. So if you have a big chunk of data that has been partitioned into multiple partitions, but those partitions are required to be adjusted, so AQE will do that at the runtime. Data skewness. If there is data skewness problem in your data or in your partitions that has been created, that can be optimized by using AQE feature at the runtime. Join strategy. If a particular kind of join strategy is going to take more time or it is going to consume more memory, then Spark AQE is going to change the join strategy at the runtime to optimize the performance. All above things are going to happen at runtime dynamically by using AQE feature to improve the performance. Once Spark complete this re-optimization, the new optimized plan is going to be executed to improve the performance. So now you have to revise each and everything. When we were running our job, at that time Spark did a lot of static planning, and after that static planning, when we run our job, we realize like re-optimization is required to improve the performance. Now we cannot do the re-optimization, but there is one special feature within Spark that is known as adaptive query execution that is going to re-optimize things for us so that we can get good performance. We can optimize the performance of Spark job. Now we are coming to the AQE definition. AQE is a feature in Spark that aims to improve the performance of Spark job by dynamically optimizing and adjusting the query plan during the query execution time. So this special feature is going to optimize the query plan, is going to change the query plan at the runtime so that we can optimize the performance of Spark job at the runtime. This AQE feature is going to be disabled by default. We need to enable this AQE by writing this particular line of code. Now we are going to understand this AQE by real-time example. In our life, we do lot of future planning, but sometimes we need to replan things based on the present situations. So this is how Spark AQE works. Now we are going to deep dive into the features of AQE. We have three kind of Spark AQE features dynamically coalescing shuffle function. Second is going to be dynamically switching join strategy. And third is going to be dynamically optimizing skew joins. So let's discuss all these three in detail. First is going to be dynamically coalescing shuffle partition. To understand this, we are assuming that we have sales data of multiple products. And in this data, sugar is going to be the most sold product. We also have some other products such as tea, coffee and water. Fine. Now our goal is to get the sales number of each product. Fine. This data size is 250 MB. Hence we are considering two partitions. So we had some data which has products sugar, tea, coffee, and we want to get the sale number of each and every product. And we had 250 MB of data, so that's why we decided to go for two partitions. So this is partition 1 with different items, and this is partition 2 with different items. Now if you observe this, this diagram, you will see sugar is going to be a product which is going to have higher sales. Now if we have two partitions, obviously shuffling is going to happen. If we want to group data, when shuffling is going to happen, this sugar and sugar is going to be combined and going to create a new partition that is going to be named as P1. And like this, tea, coffee, milk and water, everything is going to be combined and grouped so that we can get sales of each and every product. After grouping of this data, if you see these partitions, P1 and P2, 5 partitions has been created, but P1 is going to take highest time to execute the Spark job because it is going to be a largest partition. Hence, here comes the work of AQE. What it will do, it will coalesce P2 and P3, it will coalesce P4 and P5 so that we can optimize the Spark job. Once we coalesce these partitions are going to be look something like this. So if you see now, there is no partition which is going to take highest time. They all are going to take something around same time to process because P2 and P3 has been combined and P3 and P4 has been combined to make partition 3. This is how AQE will optimize the performance by coalescing the shuffled partitions. So these were the shuffled partitions from P1 and P2, and after shuffling, coalesced these partitions to optimize the performance of Spark job. Second feature is going to be dynamically switching the join strategy. To understand this, we are assuming two tables. We have two tables. One table is product and second table is sales. Product table has 10 GB of data and sales table has 20 GB of data, and we are going to join these tables based on the product name. So once we decide to join these tables, by default Spark will do sort merge join because Spark dash engine will find size large because both the tables have large amount of data. That's why Spark is going to be select the sort merge join to join both the tables. Now after reading both the tables, we applied multiple transformations to the table and we are left with a table left with only 10 MB of data in the sales table. We read both tables and we applied lot of transformations, and after all the transformations we are left with 10 MB of data in the sales table. Now the condition has been changed. One table has large amount of data but another table has very small amount of data. Now what AQE is going to do at runtime, it is going to change the sort merge join to the broadcast join, as broadcasting of this table is possible because it is going to hold very small amount of data. So since we can broadcast this sales table, that's why this type of join strategy is going to be changed at runtime. Hence this is how AQE will dynamically switches the join strategy. Third feature is going to be dynamically switching skew join. We are again considering the same condition. One is product table and second is sales table, and we are going to join using the product name. Our goal is to join both tables based on product name. In this case, we want to get the sales of multiple products which are available into the product table, where product sugar comes around 80%, rest comes around 20%. Now again, same condition we have most sold product as sugar, and it covers around 80% of data. Rest are going to be 5%. Now in this situation, sugar will have 80% of data and it is going to take highest processing time. Whenever we see such condition where a certain partition is going to hold large amount of data compared to others, this is going to be a data skew problem, because this partition is going to take highest time to process and other partitions are very small. This is how we can say the problem we have is data skewness problem. Now let's see how AQE will resolve this problem. What AQE will do? What AQE will do, it will neutralize the biggest partition into 4 partitions, so that this processing time of sugar is going to be splitted into 4 parts, and now it is going to create 4 partitions out of sugar P1 partition. So this is how AQE will optimize the problem of data skewness at the runtime. Thank you.